So now we go over the second chapter of uh, the N6 power machine course. So the second chapter is all about the integration techniques. So you did some section of integration in N5. So you touched some section that so you just did that superficially. So let's say you have x2. So they want you to derive x to the power of 2. So the derivative of x to the power of 2 can be written like this. So if we derive it, we get 2x. So the integration is just the inverse of the derivative. So now, if you know the expression of the derivative, you can get the function that was derived in order to get this function here. So this process is called integration. So I'm sure you did that in N5. So you start with the basic function, and then you also use the integration tables. So the integration of 2x is simply equal to 2x squared over 2. So all you need to do is you look at the exponent. So in this case the exponent is 1, so you add 1 to the exponent, and then so the exponent becomes 2. So now we're gonna have to divide the whole function, the whole expression by 2. So you actually have x2 over 2. So you did all this in N5. So now in N6 we actually have to look at the methods that are used to integrate a function. So the first method is called integration by part. So this method is basically used to integrate a function that is made of the product of one function and the derivative of a certain function. Okay, let's say we have a function which is made of f of x multiplied by the derivative of another function which is g of x. So now they want us to integrate this with respect to x. So all we need to do is, so you need to apply, so there is a formula that you are going to use when it comes to integrate by part. So that gives, so you actually need to have f of x multiplied by g of x minus the integration of g of x multiplied by the derivative of f of x. So to make it simple, we can just call that f of x, can call it u, and then g of x can call it v, and then repeat the dash. So it means if we have the product of u, so the function u and the derivative of multiplied by the derivative of the function v, so that simply gives u multiplied by v minus the integration of v multiplied by the derivative of u. So this expression is very important to familiarize with. So when they give you a function, okay, let's just see some example here. Okay, let's consider the first example from your textbook of N6. So let's say we have, so that the first example, so they want us to integrate this function here. So x to the power of 3 multiplied by e to the power of 2x dx. So all we need to do here is we have this function which is made of two separate functions. So these two separate functions multiply to each other. So we can call that as u, so that is the function u, and this one is called v dash, so the derivative of a certain function. So now if you replace these two elements by u and v dash respectively, so you actually have the integration of u multiplied by the derivative of v. And then if we have this, we need to use that formula that's gonna be used to integrate by part. So that gives uv multiplied by v times the derivative of the function u. So now what is u in this case? So u is simply equal to x cubed. So if u is equal to x cubed, so what's gonna be the derivative of u? So the derivative of u will be equal to 3x to the power of 2 dx. So you just need to derive. So you need to have both the function u and its derivative. Same thing for v. So you need to have v and the derivative of v before you apply this formula. Because if you look at this expression here, it involves both the function and the derivative of those functions. So we have u here, and then you can see there is a derivative of u. Same thing for v. So we have v, and then so that represents the derivative of v. So in this case we are given the derivative of v. So if we know the derivative of v, which is e to the power of 2x, so this is the derivative of v. So to get v, then we're going to have to integrate. In other words, if we integrate this dv, so the derivative will cancel, and then you're gonna, the derivative symbol and the integral symbol will cancel, and then you only remain with v. So here we have dv, and then to get v, we're going to need to integrate this function here. So v is equal to the integral of e to the power of 2x, which gives e to the power of 2x divided by 2. So I'm sure you have this table here. So you're actually applying yeah, we're actually applying the relation from this table. So if you have the function e to the power of ax plus b, so when you derive the function, this is what you get, and when you integrate the function, you just need to repeat the initial function, and then you divide by the derivative of the exponent. So in this case, the exponent is ax plus b. But if you go back to the question that we are dealing with, the exponent is 2x plus 0. So if we derive 2x plus 0, we are going to get 2. So that 2 should be, so that 2 is what we see here at the bottom. So I have u and du, v and dv. So now what I need to do is I just need to plug all these elements into this expression here. So you can say that the integral of u, so what is u? U is x cubed multiplied by the derivative of v. So the derivative of v is 2x. So that gives u multiplied by v. So what is u? So u is x to the power of 3, and then v is, all this represent v. So I need to multiply it, and then minus the integral of, so I have v, so v, which is e to the power of 2x divided by 2 multiplied by the derivative of u. So the derivative of u, I've worked this out, so I got 3x to the power of 2. It's actually what is here.
No.
Does it work?
Okay, I'll take it away
No?
now. Yeah, thank
Okay.
you.
Okay. You alright?
Yes, I'm good.
So this is what we have already. So now I need to simplify the expression a little bit. So I'm gonna have x to the power of 3e to the power of 2x divided by 2 minus the integral of e to the power of 2x multiplied by 3x to the power of 2 divided by 2. So remember, this is a constant, so I can bring it outside. So this is the same as x to the power of 3 e to the power of 2x divided by 2 minus half multiplied by the integral of, so actually you have 3 over 2. So 3 over 2, which is a constant, so it can go outside the integral. And then we have x to the power of 3 and x to the power of 2 multiplied by e to the power of 2x dx. So this is not the final answer, because we still need to integrate this part here, so until the integration sign disappears. So now what I'm gonna do is, again, I'm gonna use the relation that I applied in the previous slide, because if you look at this, what we have here, it's also a product of two functions. So we have u, so this represents u, and this one represents the derivative of v. I can call this I can call that derivative of v, and this one is u. And then I'm gonna do the same thing. So what I have here, so I first repeat everything that I have. So I have 3e to the power of 2x 2 minus 3 over 2, then integral of x to the power of 2e to the power of 2x dx. So I'm not concerned of what is on the left hand side of the integral. I only look at this part here, the part that is on the right hand side. So I'm going to call that u. So this is the function u, and then this is the derivative of the function v. So you know that the integral of u multiplied by dv, so that gives u v minus the integral of v multiplied by the derivative of u. So now all I need to do is to find the derivative and the derivative of v and u, as well as the integral. So that gives x3 e to the power of 2x over 2 minus 3 over 2, and then I open the big bracket. So I first have u, so u is x to the power of 2, and then I have v. But here I only have the derivative of v. So to get v, I'm gonna have to integrate my dv. So in other words, v is equal to e to the power of 2x over 2. So when you integrate this, you get e to the power of 2x over 2. So you just need to divide the exponent by the coefficient of, because the exponent has a linear form, so you just need to divide everything by the coefficient of x. So all this represent v, and then I say minus, what comes next? I have the integration sign, and then I have to reproduce v as it is, so that is, so all this represents v. And then next I have the derivative of u. So u represents x to the power of 2. Then the derivative of u will be 2x. And then I close the bracket. So that gives x to the power of 3 e to the power of 2x over 2 minus. So I can multiply this constant here with the term in the bracket. So I'm gonna have 3 over 4 x to the power of 2 and e to the power of 2x, and then here I'm gonna have plus 3, so these two can cancel, so I'm gonna only remain with 3 over 2, and then I have the integration sign, so I have to integrate again e to the power of 2x multiplied by x dx. So again I'm gonna integrate what I have here, what is on the right hand side of the integral sign, and I will still apply the integration by parts because I still have the product of a function and the derivative of a certain function that I'm gonna call. So this is u, and I'm gonna call that the derivative of v. So I'm gonna need to get the derivative of u and v. So if I further proceed, so first need to repeat what is on the left hand side. So I have x to the power of 3 e to the power of 2x over 2 minus 3 over 4 x to e to the power of 2x plus 3 over 2. So I'll still apply this formula here. So I have u which is e to the power of 2x. So u multiply v, but this doesn't represent v. So this represents the derivative of v. Then to get v, I'm gonna need to apply the integration to this part here. So what I'm actually doing is, so the objective is to make sure that the exponent is going down, because if you remember, we started with the exponent of x was 3. As we are going step by step, the exponent is going down. So it was 3, and then it is 2, and then it's gonna be 1. But if I try to integrate this, if I call that as u or dv, and this one is u, so I'm gonna have to integrate the x, so that's gonna be x squared over 2. So we're going to realize that, so the exponent was 1 and then it now becomes 2. So it's like I won't get anything, so I need to make sure that the exponent is going down. So the exponent must decrease. So to do that, all you are going to do is you just change, you call that, so this is u and that one is derivative of v. So now if you apply the integration, so if you apply the integration method, so you are using this relation here. So first have u, so u which is equal to x squared, and then we have v. So what does v represent? So v represents the integration of this function here, because this portion is called dv. Then to get v, when I have to integrate this part. So if, as we did in the previous step, so if we integrate this part here, you're going to get e to the power of 2x divided by 2, and then we have minus, so you have the integral of, so repeat v. So what is v? V represents all these parts. So we're going to copy it, and then next we are going to derive u. So one thing here, so that's supposed to be x only, not x to the power of 2. So here we have x. So if we derive x, just get 1, and then we have the x. So we close the bracket. So we're going to multiply the constant with all the terms that are inside the bracket, as we did in the previous slides, in the previous steps. So what are we gonna get next? So we have x. So we first repeat everything that is not in the bracket. So we have x to the power of 3 e to the power of 2x over 2 minus 3 over 4 x to the power of 2 e to the power of 2x. And then here you need to apply the multiplication. So we're gonna have 3 over 4 x to the power of 2 e to the power of 2x minus the integral of so if we have, so that can also be written as 1 over 2 and then we have to integrate e to the power of 2x. So e to the power of 2x, after the integration we get e to the power of 2x over 2. So just have to divide the coefficient of x by 2. So something here. So we have e to the power of 2x multiplied by x. So here actually have x, not x to the power of 2. So I have to change it here as well. And there. And then, so now we can say that it is completed. So the final expression is, if I integrate, what was the initial function? So the initial function was x to the power of 3 e to the power of 2x dx. So if I integrate my function, I end up to, so I have x to the power of 3 e to the power of 2x over 2. So I'm just copying what I have here, minus 3 over 4 x to the power of 2 e to the power of 2x plus 3 over 4 x multiplied by e to the power of 2x minus, so these two gives 4. So I have e to the power of 2x over 4. And then one thing I need to put it on is the constant. So that should also be there. So this is the final answer. So you need to arrange your u and your v in such a way that the exponent of, anytime you are doing the integration step, you need to make sure that one function is going is getting reduced. So like as you can see in this relation here, so I need to choose the function that is easy to derive in such a way that the derivation step can eliminate the function. Because the reason why we have choose you have choose u to be x to the power of 3 and dv which is equal to e to the power of 2x. So the reason why we choose u to be x to the power of 3 is because if I apply the successive derivation, I won't get anything in the end. So if you derive this 3 times, you will only remain with e to the power of 2x, and e to the power of 2x will be easy to integrate because you can just use the integration table to get the value of the integration of e to the power of 2x. So that's it. So now we're going to look at another question. So let's do example number 3. So it is the N6 textbook. So you have to integrate e so you have to integrate e to the power of 2x multiplied by cos of x dx. So here, if I call that, so I call that u, and that one the derivative of v. So therefore, what could I be? So u is equal to e to the power of 2x, and the derivative of v is cos of x. So if u is equal to e to the power of x, then what is the derivative of u? So the derivative of u will be 2e to the power of 2x. So I need to have both u and its derivative. So same thing for v. I need to have if I have the derivative of v, I need to make sure that I also have v. So to get v from the derivative, I'll just need to integrate the function. So if I integrate cos, I got, so that gives sine x. And the next thing is to apply this formula here. So I'm going to say that the integration of e to the power of 2x cos x dx, so that gives, so I have u, which, so the expression of u is e to the power of 2x, and then what is v? V is sine x, and then I have minus integral. So I need to repeat v. So v is sine x, and then the derivative of u is 2e to the power of 2x. So the next thing is to simplify a bit the expression. So I'm going to say e to the power of 2x cos x dx, so that gives e to the power of 2x sine x minus 2 times the integration of, I just need to bring 2 outside because it's a constant. So I have e to the power of 2x, and then multiply by sine x dx. So I still need to do the integration. So again, so I first need to copy what I have. So that is equal to e to the power of 2x sine x minus. So I need to look at the expression that is on the right hand side here, on the right hand side of the integration symbol. So again, if I apply if I apply again the same technique, so I'm gonna call that as, so this is u and that one is the derivative of v. So I've already so here I'm gonna say that u is equal to e to the power of 2x and the derivative of u is 2e to the power of 2x, and then I have the derivative of v, which is sine x. If the derivative of v is sine x, then v is the integration of the derivative of v. So in other words, I need to integrate sine x, and when I integrate sine x, I get negative cos x. So now I have all the four elements. I have u, du, dv and v. So I just need to replace. So I have u, which is e to the power of 2x, and then v is negative cos x minus integral of v. So what is v? Just copy negative cos x, and then the derivative of u is 2e to the power of 2x, then dx. So I'm going to try to simplify this a bit. So the integration of e to the power of 2x cos x dx gives e to the power of 2x sine x minus, so because we have two negative sign, so we have two we have the multiplication gives a positive, and then we have 2 e to the power of 2x cos x. So you also have the multiplication of negative sign here. Okay, this actually need to be okay, no problem. So we actually have, so we have negative, so these two gives positive sign, positive times negative gives negative, so we have negative 2. So we have another 2 there, so we actually need to have negative 4, because that 2 and that 2 multiply to each other. So we have e, so first have the integral sign, and then e to the power of 2x multiplied by cos x dx. So now if I try to integrate this again, I call it like, okay, this is u and that is the derivative of a function cos x. And then if I continue with the integration part, I'm gonna realize that it won't bring me anywhere. So this expression will keep changing. So that's gonna remain as it is there, but this one will be changing. It's gonna be as I go through the steps, so it's gonna be changing. It means the first integration will yield a cos, the second will yield a sine, and then cosine, cosine. So it will just keep repeating. But from this step, I can just realize that what I have here is the same as what I have there. So you can see that we have the term that are identical. So we have the integration sign there, and the expression, and then we can see we have the integration sign and the same expression. So these two expressions are like, so they are like them. So that means I can bring this expression to the left hand side in such a way that I'm gonna add with, so I'm gonna add it to the expression that I have on that I had on the left hand side. So in other words, I'm gonna have, so first copy this, so I have e to the power of 2x cos x dx. So when it goes to the left, so the sign in front will change. So when I have plus 4 integral of e to the power of 2x cos x dx. And then on the right hand side, I only have this part here. So I have e to the power of 2x sine x plus 2 e to the power of 2x cos x. So what's gonna happen here? So I need to work out these two because they are like term. Since they are like term, you just need to add up the coefficient. So here we have a 1 in front, and then the second term has a coefficient of 4 in front. So we just need to add the coefficient to each other. So we have integration. So we get 5 times the integration of e to the power of 2x cos x dx. So that is equal to e to the power of 2x sine x. So just repeat what we have here, plus 2e to the power of 2x cos x. Then the question is to get the integration of the function here, the integration of e to the power of 2x cos x multiplied by cos x dx. So if I integrate this, to get the integration of this, all I need to do is I need to divide both sides by the coefficient, which is 5. So in other words, I need to divide that by 5 and that by 5 and that one by 5. So the final answer will be the integration of e to the power of 2x cos x dx gives e to the power of 2x sine x over 5 plus 2 e to the power of 2x cos x over 5 plus, so always involve k. So this is the final answer. So here you just need to make sure that you need to write this properly in such a way that someone may think that we have sine x over 2. So you actually need to divide the whole thing by 5. So same thing here. So you have 2e to the power of 2x cos x. Everything need to be divided by 5. So that's it. So in the book they got 1 over 5, so which is also the same. We just need to because 1 over 5 represents the common factor of these two terms. So we have e to x sine x plus 2e to x cos x plus k. So it's basically the same as what we have. Now let's look at another example. So it's example number 4 from the textbook. So you have to integrate the inverse sine of x. So the integration, to integrate all the trigonometric inverse function like arc sine, arc cos, arc tan. So always use this method, the integration by part. There's no other method you can do and get the answer except this one. But if you look at this relation here, we can't see directly because the integration by part is basically used when we have the product of two functions. So you have first function and that multiply the derivative of another function. So like here when I look at this, so I can see like it looks that we only have one function only, which is sine x. So what I'm gonna do is I'll just put a 1 in front, and then I'm gonna consider that one as my first function that multiply my second function, which is arc sine of x. So now I'm gonna call that as dv and that one as u. So the reason why I don't need to call this as u is because as I proceed I will have to derive so that one which gonna give me 0, but when I integrate this I won't get 0. Or what we can also do is we can just shift, we call it u, and so this represents dv and then dx. So the next thing is to find, so I say u is equal to sine, the inverse sine of x. So now what's gonna be the derivative of u? to get the derivative of sine, the inverse sine, so you just need to look so you just need to use the table. So the derivative of this function here is one over square root 1 minus x squared. Then we have dx. So if my dv is equal to 1, so 1, now what gonna be the derivative? So now what gonna be my v? So v is simply the integration of dv, which is equal to x. So in other words, if we integrate 1, we get x. So now I have the 4 element. I just need to use this formula. So I'm going to say that the integration of sine, the inverse sine of x dx gives, so we have u, which is inverse sine of x multiplied by v. So v is equal to x. So I have the product of u and v, and then minus the integration of, so I have v, which is x multiplied by the derivative of u. So the derivative of u gives dx over square root of 1 minus x squared. So another way, I have sine, the inverse sine of x dx, which is equal to the inverse sine of x. So you can say, so we have x that multiply the inverse sine, and then we have x dx divided by square root of 1 minus x squared. So now the second part, so the second part is to integrate this function here. So you did that in N5. So we are going to use a method called the integration of function by substitution. So if we have, so we can do it separately. So we have x dx over square root of 1 minus x squared. So all you need to do here is, you said let u is equal to the expression that is under the square root sign. So we have 1 minus x squared, and then you derive both sides. So if you derive this side, so that's gonna give you the derivative of 1 minus x squared. So if we derive this, we get negative 2x dx. So now we are going to express this, so we are going to get the x subject of formula. So in other words, dx is equal to du over negative 2x. So now what you are going to do is, you look at, so you replace dx by this expression here. So the dx from this part. So in other words, the integration will look like, so we have x, so dx is du over negative 2x, and then we divide by, so the term, the expression which is inside the square root sign is u. So now you are going to realize that there are some terms that can cancel out. So we have x there and x there. So I'm going to remain with, so this is a constant, -2. So we just say the integration of -1 over, -1 over 2 multiplied by the derivative of u over square root of u. So now you get a simple expression that you can integrate. So you have -1 over 2. So this one can be written as du to the divided by u to the power of half. So that can also be written as -1 over 2 multiplied by the integral of, so you bring u to the power of half on top, so the sign will change. So we are going to have -1 over 2, and then we have du. So we actually, and so from this step we can apply so this rule here. If you have a function x to the power of n, so if you integrate this function, you are going to have x to the power of n plus 1, and then you divide by n plus 1. So n represents the exponent. So in this case the exponent is -1 over 2. So that's gonna give, so you have -1 over 2, we have u, so you have -1 over 2 plus 1, and then we do the same at the bottom. So you have -1 over 2 plus 1. So what are we gonna get next? So we have -1 over 2 u to the power of 1 over 2 divided by 1 over 2. So these two can cancel out. So we are going to remain with -u to the power of 1 over 2. So now I'm gonna have to replace u by x, because the function is written in terms of x, the initial function, not in terms of u. But since I know that u is equal to 1 minus x squared, so therefore the integration of this function here will be equal to -u, which is 1 minus x squared, and then to the power of half. So now what I'm gonna do is I will just replace all this by the results of its integration. So I'm gonna have, so I copy what I have there, so I have -1 minus x squared to the power of 2, and then I have here. So if I simplify it a bit, so I get plus there, and then 1 minus x to the power of 2 to the power of half. That's it. So just one thing, remember that you have k, so you always add k. Okay, that's it. So for the homework, I'll just select some exercises that are in the textbook. So if you have the textbook, okay, let me just so you can try to do the following exercises. So if you can try number 5. So the question number 5 is the integration of x to the power of 3 e to the power of 2x dx. Then you also do number 8. So the integration of e to the power of x sine x dx. And then there is 12. 5x plus 2 cos x dx. And then 15. So you can also do number 20. '23. '24. So 24 is most likely what we've just done. So it's most likely to what we just done, but except that here they use 2x instead of x. And then the last one is the integral of x to the power of 2 cot -1 x dx. So that's it.